notation. And today we're just going to do a little piece of scientific notation. We're just going to do the big numbers. Big numbers. Okay. And I guess the point for this is, when it comes to science, 7th graders, quite often you use incredibly large numbers. For example, when you talk about how far the Earth is away from whatever other galaxy, you know, how big the Earth is and whatever. One of the problems you end up with is that, you know, you start adding a whole bunch of digits together, you kind of get lost in the shuffle of it all. You know, for example, if you had the number, you know, 750000000000000, you know, we'll put our commas in there. And it's not so much the issue of being able to read that number or say that number. It's if you start doing math multiplication or you start doing math processes with that. You know, if I told you to multiply that by 7,200 or whatever, the digits start getting all mixed up. You got to try to keep all this stuff straight. So the scientific people came up with what's called scientific notation. Okay, and it's based on this. The first thing you must understand is that it does a lot with exponents of 10. 10 to the 0 power, 10 to the first power, 10 to the second power, 10 to the third power, 10 to the fourth power. I can't put it there, sorry. Let's just do 10 to the fourth power. What do these things equal? 10 to powers is the easiest thing in the world you can do with exponents because 10 to the 0 power is 1. 10 to the first power is 10. 10 to the second power is 100. 10 to the third power is 1,000. 10 to the fourth power, and so on and so on. It's easy to remember what these are because whatever the exponent is how many zeros there are at the end of the 1. Okay? So there's one exponent of 1, 1 0. Exponent of 2, 2 zeros. Exponent of 3, 3 zeros. You know, exponent of 4, and so on and so on and so on, etc., etc. Okay? Well, here's what happens with scientific notation. Scientific notation must always end up looking like this. 9.3 times 10 to the 6th power. When something is written in scientific notation, the first thing is this. The number in front of the times sign must be between 1 and 10. 9.3 falls between 1 and 10, so that works. Okay? This, you always will have a times 10. Okay? You'll always have that. And then you have an exponent that goes with that 10. Now, if you were going to tell me what the real number was for 9.3 times 10 to the 6th power, well, we just talked about 10 to the 6th power is the same thing as 1 with 6 zeros. So this is the same thing as 9.3 times 1 million, which happens to be 9,300,000. Right? Okay, this right here is the same thing as 9,300,000. You really don't have to kind of get all this, you just have to get the process of it all. Okay, we won't work with multiplying and dividing for a little bit later, but you just need to understand that. So here's the deal. Let me give you, let's say I have 460,000. And I want to make that in scientific notation. Make it in scientific notation. Step number 1 is you must move the decimal so the number is between 1 and 10. Which simply means this, decimal starts here, if a number doesn't have 1 in it. Where do you move it so that it's between 1 and 10? Well, it has to go here. This number's not between 1 and 10 because that's what, 46,000. 4,600, 460, 46, bam, right there. Between 1 and 10 means you would make this 4.6. Really, the one thing to know is that you move the decimal so there's one digit that's not a 0 to the left of it. Okay? That 4 is between 1 and 10. Step number 2 is a very simple little step. Step number 2 is you write times 10 down. So this is going to be 4.6 times 10. How easy is that? Okay. And then step number 3, you have to figure out what the exponent of 10 is going to be. Guess what the exponent of 10 is going to be? There's one really simple rule. I'll just tell you. The exponent of 10 is how many places you move the decimal. In other words, this. The decimal started here. How many places did I have to move it to get that number between 1 and 10? I moved it 1, 2, 3, 4, 5 places. That is what exponent of 10 goes up there. God bless whoever was sneezing over there. This is the same thing as this, but this is in scientific notation. Because really what you did, I mean, if you were doing this all back out the other way, this is 4.6 times 10,000. No, 100,000. Right? Because that's what 10 to the 5th power is. And 4.6 times 100,000, you just move the decimal over 5 places that way, is going to get you back to that number you started with. But this, when we do big numbers and small numbers mathematically, if we write it like this, it's a lot easier for us to work with in the end, trust me. Another one. What if I have 75 billion? 1,000, million, billion. And you were asked to write that in scientific notation. In sci notation.
I always leave my keys in your room, Mr.
Wait, you
Connor.
sure those are yours?
Yes, they are, because they have my
Just like
jewels on
mine.
them.
Oh, they have whistle. Follow the steps there if you go on scientific notation. If I move the decimal and make it between 1 and 10, where does it go? Somebody help me out with this. Faith?
Between the 7 and 5.
Correct. And you must, by the way, children, I didn't say this before, you have to write down all the digits that aren't 0 after that decimal. In other words, if this would have been 7, 5, comma, 4, 3, 2 with all those, you would then have to, you would have to still write that 4, 3, 2 in there. You don't just stop after the first one, however many non-zero digits are is how many you have to write after that. But we don't have it there, so. Alright, 7.5, the next thing I do, Jacob Licht, is write down
10
times 10. What is going to be the exponent of 10? That is how many places, Brand, did I move the decimal?
10.
Let's check and see. It was 3 to get to here, 6 to get to there, 9 to get to there, 10 to get to there. Uh-oh. Ladies and gentlemen, we have an issue. 10. And that is 75 billion in scientific notation is 7.5 times 10 to the 10th. Now, in addition to that, young fair 7th graders, you also must be able to change scientific notation to standard notation, which is what we normally have. So if I gave you this, 8.763 times 10 to the 9th power, and I asked you to make that in standard notation, you would have to be able to tell me what that would be. And the only thing you have to remember is this little exponent up there, that's how many places you move the decimal to the right. Exclamatory pointo. Okay. That means this. Okay. I start with 8.763. I need to move this decimal 10 places over there and fill in the empty blanks with 0. So it works like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of those become zeros. And then you want to put your commas in there. So that ends up being 8, 7, comma, 6, 3, 0, comma, 0, 0, 0, comma, 0, 0, 0. 87,630,000,000. It's pretty simple. Maybe a quicker way to think about it is this: if you're moving the decimal 9 places, 3 of them are going to take up with the zeros, the non-zero digits there, and then you'd have to have 6 zeros after it to fill in the rest, giving you a total of 9. 6, 7, 8, 9. Good point, Mr. Hall. Thank you for all that. How about this one? 1.609 times 10 to the third. What would that be in scientific, or in standard notation? Because it's in scientific notation. What would it be in standard notation? 1.609 times 10 to the third is, moving that decimal, Evelyn?
1,600.
Correct. This little 3 tells you move the decimal 3 places to the right. If you do that, it ends up at the end of the 9, 1609 decimal point, so it's just 1,609. How about 3.05 times 10 to the 6th power? What would that be in standard form? 3.05 times 10 to the 6th. What would that be in standard form? Who thinks they have a fair and actual reasonable guess at this one? Actually, it shouldn't be a guess. You should have this one. Tyler says,
3,050,000.
let's check and see. Move the decimal 6 places. 2 of them are going to be taken up with that, so that means you're going to add 4 more zeros. 305 with 4 zeros gives you 3,050,000. How about this? Make this in scientific notation. 70,500. Change that to scientific notation. What is 70,500 in scientific notation? Carolyn, what did you get?
7.05 times 10 to the 4th.
I believe you are correct. The decimal starts here, moves 4 places to get there, so it would be 7.05. You gotta keep going till you get, so there's no zero, times 10, moved it 4 places to the 4th power. Problems? Anybody think they need some more to do on that? They pretty much got it. Get this done. Oh, yes. .05 times 10 to the 4th. Okay?